Alright, so we're looking now at derivatives of logarithmic functions. And again, this is just a rule that you need to know. If our function y is the natural log of x, then the derivative is 1 over x. If y is the natural log of x, then the derivative is 1 over x. Now again, this is one where the rule itself is not that hard to remember. However, it's very easy to forget when and how to use the chain rule in this case. Okay? Now, if you're going to end up using the chain rule, as it shows here, notice that the function, the inner function, is going to be inside this natural log. Okay? It's going to be inside the natural log. So look for that. Okay? Here's the example. We have natural log of 1 minus 3x. Okay? Again, we have a chain rule that we have to deal with. So when we're finding dy dx, what's the derivative of a natural log?
1 over.
1 over, okay? And it's 1 over
-3.
whatever you happen to have in here, okay? So it's 1 over 1 minus 3x. But then here's the chain rule. We need to multiply it by the derivative of the inside, right? -3. Okay? So we have -3 over 1 minus 3x. Okay? So again, notice here, we look back at our rule. Natural log, the derivative is 1 over x. When there's a function in here, it's 1 over the function times the derivative of the function. Okay?
It's just like this, like square root, just do like, it's just like whatever happens to the function, that's what it is. I don't know. It makes sense.
Okay. You know, another one here, if we had the natural log of, let's say the natural log of the square root of x. Okay? We would do 1 over the square root of x, but then we would need to multiply that by the derivative of the square root. So 1/2 x to the -1/2. Okay? And actually, if you simplify that, you actually get this is 1 over the square root of x, so you get 1 over the square root of x times 2 times the square root of x. So it's 1 over 2x. Okay? Now, think about that for a second. Think about what you know about logarithms. How could I rewrite this? Okay. What could I do with that?
1/2 times.
1/2 ln of x, right?
Yeah.
What's ln of x? The derivative?
1 over x.
1 over x times 1/2 is 1 over 2x. Okay? So here's a case you could use the chain rule, or you could use some of your logarithm rules to help you simplify that a little bit. Okay? We'll take another look at that here in a minute. Okay? Where we can use those rules for logarithms to help us figure it out. But But let's do one more here, just using a regular ln of x. What would I need to use in this case to find our derivative? Product rule, okay? Y equals x cubed times the ln of x. So u is x cubed, v is ln of x, u prime then 3x squared, v prime is 1 over x, okay? So, using our product rule, dy dx, u prime v plus uv prime, u prime 3x squared times v, ln of x, plus u, x cubed, times v prime, 1 over x. And we simplify a little bit here. We have 3x squared ln of x plus x squared. By the way, notice only that x is in the ln.
No, just follow up after that. Could you factor out x squared?
Yeah, and that would actually be a good idea, especially looking forward to when we're going to have to solve for when these equal 0. Factor out the x squared, and you get 3 ln of x plus 1 in the parentheses. Okay? Good. Any questions so far? All right. So let's do quickly look here at our rules for logarithms or properties for logarithms. Okay. These can make finding the derivative a little easier. Okay, but we got to remember them, of course. The natural log of a times b, if you have multiplication inside the natural log, then you can split it into two separate natural logs added together. Okay? And remember, that's because if we are multiplying things with the same base, we add the exponents, right? And then likewise here, if we're taking the natural log of a over b, when you're dividing things that have the same base, you subtract the exponents. So you can do ln of a minus the ln of b. Okay. And then the one that we just saw there with the square root, ln of a to the n, whenever you're taking a power of a power, you can multiply the exponent. So it's n times the natural log of a. So how could this be used? Well, let's look at what we would have if we didn't see this. Okay? If we didn't use the rule, this is what we'd have to do. We would have a chain rule problem. Okay? dy dx, and we would do, for the natural log, we would have 1 over whatever's in the log. So x e to the negative x. The problem is this, then we have to multiply by the derivative of what's in there. What am I going to have to do to get the derivative of what's of the inner function here?
You have to do
Product rule, chain.
Yeah, we'd have to do the product rule, and even in the product rule, we're going to have to use the chain rule. Okay? Which we can do. I mean, if you make this u and this v, u prime is 1 times v plus u times v prime, so that's e to the negative x times the negative 1. Okay? And it's doable, but it's messy. Okay? We've got 1 over x e to the negative x times, we could factor out an e to the negative x, and we'll get 1 minus x. And then, hey, what do you know? There's an e to the negative x we could cancel. So on now I just have 1 minus x over x. That's not too bad.
Can you split up natural log of x plus natural log of e to the negative x?
Yes, and that's a whole lot easier. Okay? This is what would happen if we forget about these. Okay? However, if instead, we can ignore this for a moment, if instead we rewrite this a little bit and make it y equals ln of x plus ln of e to the negative x. First of all, what is ln of e to the negative x?
They cancel out the ln and the e, so it'd be negative x.
Yeah. So this would just be the ln of x minus an x. Because, excuse me, the natural log and the exponential with the base of e are inverses, so you get just the exponent left over. Well, what's the derivative of ln of x?
1 over x.
1 over x. And the derivative of minus x?
Minus 1.
Minus 1. Okay? You can see how we're getting there. I mean, I would leave it like this if I had done it this way. Okay? If we had kept going with this, we could have rewritten this as 1 over x minus x over x. And there you can see we would have the 1 over x minus 1. Same thing. Alright? But a whole lot less work. You have to think, but if you think, it saves you work. Like most of life. Alright? Does that make sense?
Yeah.
Okay? Now this one is a real mess, and I'm not even going to bother doing it without using the rules, because here's the thing. We would have to do the chain rule, and then when we did the chain rule and did the derivative of the inside, we'd have to use the quotient rule. But as we're doing the quotient rule and we're finding the derivative of the denominator, I would have to use the product rule. Okay? I really don't feel like doing all of that. Okay? So, how would I rewrite this first of all? Ln of x squared. Okay?
Minus natural log of x plus 2 times x plus 3.
Okay?
Now could you do minus l, like in parentheses, minus ln x plus 2 plus?
Well,
Yeah,
ln
you
x
do
plus
plus.
3. Yeah. 'Cause you-
Okay.
Oh, I see.
And then
We can do
plus,
this.
Yeah, can you do that?
We could do that. And to make things even simpler, I would go ahead and distribute the negative. Okay? So it's ln of x squared minus ln of x plus 2 minus ln of x minus 3. Okay? And if you want to, what could we do with this ln of x squared?
2 times ln of x.
2 times ln.
Yeah, let's make it that. Alright? So we took one that would be really a disaster to try to do using the chain rule and the quotient rule and then the product rule all in one big problem. And we now made it into something actually pretty simple. So we have 2 times natural log of x. So what's our derivative there?
2 over x.
2 over
2 over x. Okay. Minus,
1 over x plus 2.
good, 1 over x plus 2 times the derivative of the inside, which is just 1. Okay. Minus,
1 over x minus 3.
good, 1 over x minus 3, and the derivative of the inside is 1 again, so it's just that.
And should we make a common denominator or just leave it like that?
I would leave it like this at this point, unless we have a purpose of to put it all together. Like, if this were a problem where it said, where does this equal 0,
Okay.
then I would bother doing that. But that's a very simple form, so I wouldn't mess with it unless I have to. So, pretty straightforward. Again, it's not necessarily complicated to know the rules, it's just complicated to remember all the rules as you're doing the problems, okay? Alright, let's try a couple from the end of the practice. I'll let you guys practice some of these. There's plenty. Number 1 is A through N. So you have plenty to practice here. And if that weren't enough, number 2 they made A through I. Okay?
So you went easy on us.
Alright, and then number 3 went A through I as well. So there's a lot here. These ones particularly, notice the directions. It says use the laws for logarithms to help you differentiate. Okay? So please don't use the product rule, rewrite it. Don't use the quotient rule on I, rewrite it. Okay? But let's try number 4. I'm going to leave 5 for you guys to try on your own, because that's a good thinking, problem-solving one. Okay, let's try number 4. Okay, find the gradient of the tangent to y equals x times ln of x at the point where x equals e. So someone put this in your own words. What are we doing here?
L and E cancel each other out. Right, so
Well, I mean, in the whole problem,
Finding the derivative.
finding the derivative, when they say the gradient of the tangent, anytime you even hear the word tangent, think derivative. So we're finding the derivative, and then what are we doing?
Plugging in.
Plug in e. Okay?
Just be 1.
So that's this whole problem here. Find the derivative, and then plug in x equals e. Now, a little thing here, make sure that you don't plug in e before you take the derivative, okay? Because if you plug in e, then you have a constant and your derivative is 0, okay? So make sure that you take the derivative first. What are we going to use here? Product rule, all right? So what's u prime?
L1.
1 times ln of x plus,
x times 1 over x.
oh, okay. So here's u prime v plus u v prime. So we have just ln of x plus 1. All right? So we've done the derivative. Okay.
It's just 1.
So now we're plugging in e. The ln of e, what is the ln of e?
1.
1. So that whole thing is 2. So the slope of that curve, that function, at x equals e is 2.
So when ln is to e or when e is to ln, those cancel. But if it's not multiplied like that, but if you plug in e, it'd be 1.
Mm-hmm.
All right.
Yeah,
Yeah, because
and think about it, this is e to the first.
Yeah.
So, yeah, the natural log of e to the any power is the power. Or if you have e to a power that has a natural log of something, it's the something.
Gotcha.
Okay. So these are inverses of each other. Okay. All right. So